Hello and welcome to Slooh's latest Clubhouse clip. I'm Eric Edelman, broadcasting to you from the clear, beautiful skies at Smoky Hollow Studios in Slooh HQ, Washington Depot, Connecticut. Tonight I am joined by Slooh astronomer Bob Berman, who will be telling us a lot of very interesting things about objects that are very, very, very wonderfully, beautifully visible tonight. What we're looking at right now is the clear sky above the Canary Islands. We've had a lot of luck recently with some clear skies over there. There's a little bit of, you can see sort of wisps of clouds along the side, but oh, let me tell you, the live views are just about coming in, and it's really looking like some sights that you are all going to very much enjoy seeing. So without further ado, I wanted to welcome Bob Berman, who's with us here tonight. Thank you very much, Bob, for joining us here. It's going to be quite a fun night.
Yeah, it's a pleasure, Eric. Very exciting. Very exciting.
Right. Right. And yeah, I mean, really, I'm seeing the view on the computer here, and I want to get this up because we have something gorgeous planned here. Let me get our heads actually out of the way. And here is the first star cluster of the night today live, M13.
Well, M13, you know, what can you say? This is just gorgeous. It's maybe the most famous star cluster of all. It probably is the fourth or fifth brightest in the heavens of the 150 known star clusters. Excuse me. They're all in our Milky Way galaxy. Star clusters of the globular type, I should say. And you know, we who live in the northern hemisphere, this is the showpiece of globulars. So, I mean, what do you think, Eric? Isn't this gorgeous? Thing of beauty, isn't it?
There's so much activity going on there. It's absolutely incredible. I mean, like the sort of one of the taglines of the show is sort of going through the Milky Way metropolises, and this is a busy city of stars if I certainly ever saw one. Do you have sort of an idea of how many stars that we're seeing in this field here? So many.
Well, it's sometimes listed as a million. It's probably a couple of 100 1,000 stars short of a million, but uh, wow, it's just a favorite of backyard amateurs, and with our giant Slooh telescopes, you just can't get better than that. We're going to have color streaming in a minute. Just look at the bright stars and look at how the center is even a little overexposed because they're so concentrated. But what I'd like to bring your attention to are the fainter stars. When you go out from the center, you reach an area where, yeah, there's a lot of bright stars, but look at all those little guys that are everywhere. And that's one of the reasons this is so famous. I'm sorry we're showing this first because this is the largest of the globular clusters we're going to be looking at tonight. We're going to be looking at three. This one's twice the size of the others, slightly farther away than the others, but at 25,000 light years, it's still not that far so far as, objects go. The Andromeda Galaxy is 2.5 million light years, and this is 25,000 light years. So we're talking about something that's 1,000 times closer than
Well,
than that. And gorgeous. It's as old as the universe. This is one of the oldest known globular clusters in the heavens. And because of that, the stars that formed at that time were made of early universe stuff, hydrogen, helium. That's all there was around that time, just a little bit of lithium. And therefore, there wasn't the material to make planets. Our sun is a third generation star, so there's a lot of dust and carbon and oxygen and even iron and things around to form the cores of planets and our beloved Earth and the blood in our veins and that kind of thing, but not back then. So it would be interesting if we could somehow magically know how many of these stars had planets. I'll bet relatively few.
yeah, yeah. This is globular clusters are a unique whale in terms of planet hunters because I don't think there's been an exoplanet, a planet around a star other than our sun that's been found in a globular cluster. In open clusters, it's a different story. The younger
Right.
clusters, not the ones that aren't quite as old as the universe, that have those metals that we're so familiar with in our planet, in our own bodies, and so it's quite an interesting investigation. And I think that you were talking a little earlier about the Arecibo message, that there was a message that was sent out in particular to this globular cluster to see, hey, maybe we can get a response back, a little bit of a ringing the doorbell of this globular cluster and seeing who answered.
Quite right. 1974, using the giant Puerto Rico Arecibo radio telescope, beaming a message. Now, of course, at the speed of light, it's going to take 25,000 years to get there. So if we said, hello, 25,000 years from now, if there are any life forms listening to the correct wavelengths, they'll hear it. And if they answer right away, and I hope they're going to be prompt about it because we would have waited that long, 25,000 light years later, that is 50,000 light years from 50,000 years from 1974, we'll get the answer, well, hello back, how are you? And then we'll send the message, hey, we're okay, we're cool, how are you? What's happening? And then another 50,000 years later, we'll hear, well, not much. You? What's going on? So it's going to be a very slow conversation, but it's kind of cool that we did it. Members of Congress at that time some of them were up in arms about it, wondering whether it's a good idea to really announce our position, which is what we did, our location, the fact that we are intelligent life forms and where we're located to
and
so many possible planets at once, but we did it. There's no taking it back.
and look at the color that's coming into this image now, and we're seeing sort of the diversity of the stars here, that they're not all, they don't all shine the same, and they're just but it's so gorgeous to look at this zoo of
It
stars.
really is. But notice the predominant color are oranges. They're whites and oranges. We don't have a lot of blues. There's a few blue stars there, some of which I suspect are even foreground stars as we look at this. Um, but here's something cool. If you could shoot an arrow through this thing, Eric, the odds are that it would not hit a single star. This globular cluster is 150 light years across, contains almost a million suns, and yet even in the center, where the stars seem to touch, there's still an average of a quarter of a light year of space. Now, a light year is 64,000 astronomical units, Earth Sun distances. So we're talking about a quarter of that. So 16,000 Earth Sun separations, even in the center between stars. So it looks crowded, but it's less crowded than it appears.
And yeah, I think that speaks a lot towards the question that I got a lot as I was studying astronomy, which was if the Andromeda galaxy, as it's coming closer and closer to us all the time, it collides with the Milky Way. What does that necessarily mean in terms of a collision? Will we get a lot of stars colliding? And not really, just
No,
because there's so
no,
much empty space.
absolutely. Stars on average in a galaxy are 1 million star widths apart. Galaxies in the universe are on average 20 galaxy widths apart. So that's why you do have galaxies colliding, you don't have stars colliding. I mean, you can, and actually in some globular clusters we do because it's so crowded, but obviously it's rare. The other thing, cool thing is that this was discovered by the famous Charles Messier. That's why it's M13. It's the 13th on his list, and we're going to talk about that because for about 20 years, he and his assistant, Pierre Méchain, this was the cat's meow. These were the guys. This was the Neil deGrasse Tyson and the Carl Sagan and the greatest astronomers of their time. This is before Herschel started doing his discoveries, a good half century after Edmund Halley was famous for the things he did as the astronomer royal of the in England. And so this was the time of magnificent discoveries. I saw a copy of Charles Messier's notebook, Eric, and what he wrote about this discovery. And you know what he wrote about this? He said, "This is a perfectly round nebula, which I am sure contains no star,"
And
which
look
is
how
a
far we've
testimony
come.
for how absolutely crummy his telescope was. I mean, this poor guy on a Paris rooftop trying to look for comets and a telescope that would not show a single star. When we look here, that's all there is. That's all there are stars. And in fact, we'll explore that as we go to our next object. And what are we seeing here?
Oh, this is a gorgeous one. I believe we're seeing the mirror ball, as we're calling it, on
M
M10.
M10. M10. Now, this is really, really fascinating that this is what our members are choosing to look at tonight because we've just gone from a globular cluster that was 25,000 light years away to this one that's about 14,000, in other words, half the distance. This is twice as close, but is it twice as big? No, it's not even quite as large appearing. Now we're using the same magnification, same telescope, same magnification on an object that's twice as close, and yet it's either roughly the same size or maybe even slightly smaller, which tells us that this is a diminutive globular cluster. This is inherently a much smaller one, and right away this reveals to us that globulars come in different sizes. This one has a little bit more metals than M13 did. It wasn't born when the universe was born, the way the one we just saw was M13, but this is still relatively unrich in metals. And when astronomers say metals, I know you know this because you have a degree in astronomy, Eric, that astronomers, oddly enough, call everything except hydrogen and helium a metal. We're an odd bunch, you know. We call the quarter moon the half moon. You know, only in astronomy is half and quarter mean the same thing. So, but this is our nomenclature, and so this is our metal poor globular cluster discovered in 1764, if I remember correctly. So we're looking at an object, and the next one we look at will be the final object that Charles Messier and his assistant Pierre Méchain discovered. This was the time of the great French discoveries. They started in the mid 1760s. They finished up in the early 1780s, and those were the 20 years when these guys reigned supreme. After that, William Herschel, who built the largest telescopes of his day, 48-inch telescopes, not like the little 6-inch small telescopes that Charles Messier was using. Obviously, when William Herschel looked at these things, he was not going to scribble in his notes, here's a cluster, here's a nebula that contains no star. He could see that all it is stars. And that's what's interesting about the globulars is that unlike our open clusters, the Pleiades, the double cluster in Perseus, the Hyades, M44, Persepi, they all formed out of really recently out of nebulae, and sometimes the gas and the dust still lingers in its vicinity, and they're so sparsely spread apart that the stars are each going to escape the gravitational clutches of the collective, of the Borg collective. They're gonna they're going to get away. And that's why these clusters never get old. You never see, or almost never see. I shouldn't say never, but you almost never see a truly old open cluster because by the time the stars have reached even middle age, they've gone their separate way, and there is no cluster. But look at this different story. This is they're hanging together for 10 billion and more years.
And it will be really interesting, I think, to see as this image comes into color, how that color profile perhaps differs from the older globular cluster that we saw, if there will be a difference. I'd like to see what happens there.
Well, I would expect not because, as you know, blue stars are young stars automatically because a blue star means it's shining with such ferocity, such heat, that the core temperature is high, and it's high because it has a higher mass. So these stars cycle through their lifespans in no time. A blue star, if a blue star can live to be 1 billion years old, that's an achievement. And these globular clusters are many billions of years old. So the blue stars have all evolved and gone their separate ways. Now, once in a while, you'll see a few blue stars that are called blue stragglers, and we wonder how the heck did this happen? What is that doing in the star cluster? And the conclusion, which is an amazing one, is that they are the result of collisions between these older stars. Now, that suddenly gives an infusion of extra mass into this new formed star. Extra mass means higher temperatures, and now suddenly you have a newborn, super hot, blue colored star among them. So let's look and see if we can see any blue stragglers when the color comes in. Yeah, that was a great idea you had.
Right, and like you were mentioning before with the M13 that there was a lot of yellow, and I'm wondering will it be more yellow than even that was in terms of like the redder you get, the older the stars, the more mature, the longer lasting. So I'd love to see what's going to be coming in here very soon with M10. So I mean,
Yeah.
this is what we're doing. We're going through these live images where first they come in black and white, and then the color view is coming into you. Oh, there it
And
is, right here,
there it is.
live
And look at that. And
processing.
there is that warm color, that yellow color. Now, there's just a couple of blue stars, very few. Uh, Looking at them, I can't tell whether that's a blue straggler inside the globular or a foreground star in our own Milky Way. But one thing's for sure, the overwhelming consensus of these stars are on the warm side, or on the orange and yellow side of the spectrum, and that's just what you'd expect for the old population of stars that we form. It's actually a very nice star cluster. I think we've given short shrift to this. Thanks to the Great Slooh telescope, the capability, we're seeing M10, which is an often overlooked globular cluster in Ophiuchus. This looks darn good.
It really, really does. And we have to give our props, of course, to Slooh Observatory manager, community manager, Paul Cox, who was just mentioning to me that if you think that the star clusters look particularly amazing tonight, it's because he's just very recently cleaned the optics for the T1 telescope, which we're looking through right now live. With what is that? It's a CO2 snow
CO2,
gun.
that's what's used. Yeah, yeah, that's the safest way to clean professional optics. You don't really want to scrub it. That CO2 is great, but this looks like a ball of snow. I mean, it's just wonderful. Now, this globular cluster is racing away from us at 40 miles per second, in keeping with what many people think of as the universe. The universe, everything's expanding away, but that's not true within any particular galaxy, and this is just within our Milky Way galaxy. Just as many objects are approaching us as going away from us because we're all on the same carousel. We're all going around the Milky Way center. But globular clusters are famous as the most famous halo objects. So instead of being part of that flat pancake like or CD or DVD like flat plane in which we see the actual Milky Way going across the sky in open clusters and most of the bright stars, these form a halo, a sphere, a globe. So, Eric, it's balls within balls here. I mean, we're having a ball. What we have is the stars are spheres. Look, they're forming a structure here, a globular cluster by its very name. It means it's a sphere. Each one of those stars we're seeing is orbiting the center of their globular cluster in an orbit which is largely round. Some of them are elliptical, but largely, now we're talking about round circular orbits. And then, as if that's not enough, the globular cluster itself is circling the center of our galaxy, along with the other 149 members, other globular clusters. They form a giant sphere or halo surrounding our Milky Way's core. So it's globes and spheres within spheres. The only thing that's different about this one, M10, as I recall, is that its orbit is rather eccentric. It's got the same ellipticity or eccentricity as the planet Mercury, an eccentricity of 0.21. So just as Mercury comes near the sun and then thankfully retreats, otherwise it would be even hotter than it is, so does this globular cluster. In doing so, it crosses the plane of the galaxy every 53 million years or so. And it's just about to do this because in Ophiuchus, that lies not too far from the Scorpio-Sagittarius border, which is where the Milky Way runs. In fact, the brightest part of the Milky Way, the center of our galaxy. And once this goes behind the core of the galaxy, nope, I take it back. It will never pass behind the core of our galaxy because it's only 14,000 light years away. It's on our side of the core of the galaxy. So that's one reason why we see it so clearly. It's quite close to us. One of the closest globulars in all the heavens. In fact, it's almost in competition with some individual stars. The star Adera and Aludra, Epsilon Canis Majoris, are about 3,000 light years away. So this is only a few times farther away from that. Now we go to yet another globular cluster, also in Ophiuchus, and this is, drum roll, Eric?
M107.
M107. Now this is very cool too now. Now we're looking at another globular, again, roughly that same distance. That is quite a bit closer than our first one, the Hercules cluster. And yet this one also is not very big. So closer than the great Hercules globular cluster M13, and yet not bigger appearing, even though we're using the same telescope with the same magnification. Bottom line, this one's the same size as M10 that we just saw. They're matching. They're twin globular clusters. This one's about 80 light years across compared to M13 is about 150 light years across. So if you could travel at the speed of light and go from Boston to Hollywood, and then back to Boston, back to Hollywood, and back to Boston, back to Hollywood, you do 60 trips in 1 second. That's the speed of light. 186,282.4 miles per second. Whew, fast. Well, if you could go that fast, the speed of light, you could cross this thing from one side to the other in 80 years, a long human lifetime. So that's the diameter of it. The bright part is about half that, but that's the diameter of this. Same exactly as the diameter of the last globular we saw, M10, but here's the difference. The other one was racing away from us at 40 miles per second. M110 is rushing toward us at 90 miles per second. So as we're sitting here chewing the fat about it, just talking about it, Eric, every second it's 90 miles closer. Kind of cool. Shows that not everything in the universe is going away from us.
Yeah, it really is representative of that whole chaos, and I'm loving the objects that we're able to see tonight. In that we are getting a really great sample, and you were mentioning earlier, it's like apples to apples because these are all the same type of object. They're all globular clusters, and we're seeing them from the same field of view. So we're seeing them all from that same perspective and able to compare them. And really seeing the majesty of M13, but also compared with the really the beautiful characteristics of these other clusters and we're going to see the color coming up here, and it will be amazing to be able to compare that as well. There's so much to be explored in these really these old leviathans of the galaxy's past. These are the birthplace objects. And really, one thing I was curious about: how are these globular clusters in relation to the age of our solar system?
Well, our sun is about 4.55, 4.6, some say 4.64 billion years old. And these are, M13, as one of the oldest globular clusters, was essentially born when the universe was born 13 billion years ago. This one is not quite as old, but you're still talking about something in the area of 10 billion years. So more than double the age of our sun. And back then, you certainly didn't have third generation stars. Now, by a generation, that means this. These are the early stars that first formed from the universe's primordial ingredients, hydrogen and helium. If a star had enough mass and turned into a supernova and exploded, threw its contents into space, and if some of that stuff contracted a cloud of hydrogen gas just minding its own business, the impetus uh, could give birth to a new generation of stars, but this one would be richer because supernovas have heavier elements in it. In fact, in a supernova, by fusion, you can get nickel and iron and even uranium. There's only one atom of uranium in the universe for every trillion hydrogen atoms. I happen to know that fact easy because 1 trillion is such an easy number. So it's not often you find that, but you didn't get the richer stuff until stars had time to grow up, supernova, if they were going to do that, form another generation of stars. So our sun is a third generation star. That's why we've got all this richness in our bodies, on the planet Earth, and in the sun itself. You look at the sun with the spectroscope, and there are the lines of magnesium and manganese and copper and that famous double line of calcium and the K line of potassium. Lots of rich stuff in the sun. Iron, not here. We look at these stars, and this is plain vanilla hydrogen that we see here, and helium, the initial constituents of the universe. What's odd here is if we look closely, we'll see a few patches of kind of a dark patches. That means that there's some dusty. I don't know if it's gas or just dust, and it's very unusual for a globular cluster. Also unusual is that this stopped the process. This was almost the very final thing that Charles Messier and Pierre Méchain discovered. It was not in Messier's catalog originally. Um, there was a notation that they intended to add it in a later edition, which never came out. So in the mid 1940s, an astronomer decided to add this to their original list, and so M107 has only been an M object since the 1940s. It was discovered by them, but not really added to the catalog
and
until then.
And look at the live color coming in here, Bob. We're finally getting that uh, that final third color image coming in here, and it's so gloriously yellow, so very gloriously yellow.
Gold. It looks like pieces of gold, doesn't it? I mean, that's the most gold-looking globular cluster I've seen. Now, I'm not sure why it looks more golden than the last one. Don't you think so?
Yeah, you're really like I'm not seeing as many blue. I think there's maybe a couple blues that seem like they might be background stars. But yeah, it's very significantly yellow. And I mean, there's so many factors that go into play with globular clusters. They all might be very old and very large and tend to be out of that plane, that pancake of the galaxy. But there's different things in terms of metallicities, populations, and these clusters can interact with other parts of our galaxy. And so this color allows us to read a little bit into their history and to explore that mystery just a little bit.
Yeah, it's quite lovely. I would say of the three, this is probably the lesser in terms of just sheer beauty. M13, what can compete with that? There's only a few globular clusters, M22, Omega Centauri, 47 Tucani, that are, maybe M15, that are as detailed and large and bright. It's naked eye. We started off with 13. And even though it's the most distant of these three, this one's about 20,000 light years away. Our first object was 25. Our second one, M10, was 14,000 light years away. So all roughly the same distance. And I'd say this is the skimpiest, I think, of the three, the least, you know, the least full of stars of our three globular clusters. Would you agree?
I would. It's definitely that we started with dessert first tonight. I suppose I would put it that we had we had that celebration first, and then we got to the appetizers by the end. But I still thought, all in all, all the courses were pretty good overall, in my opinion. I think we had quite a fun time, and just to sort of show you guys sort of behind the scenes here a little bit, like this is the reservation plot. This is where we take all our reservations, and this is where the magic happens here. And so yeah, just giving you an idea. Here's our M13, our M10, and our M107, and this is where Slooh members get all of their ducks in a row every night, and it's quite a lot of fun. But yeah, taking you over to the clubhouse. There's really a lot to be had here, and again, we are very happy to welcome all you new members in, people who are maybe still getting their sea legs here. We love to take sort of the ends of these shows to show you around just a little bit. And so, of course, live shows might be why you're here, that we have a lot of opportunity to watch old shows and new shows coming up all the time. But you can find shows in, spoiler alert, they're in shows. And of course, to give you an idea of what's coming up, we have a lot of different meteor showers. Meteor showers are back in vogue. This is the time of year, again, where we're getting the Lyrids, the Adiquarids that are coming up. And we're also going to be talking a bit about the end of an interesting mission, a NASA mission of the Messenger spacecraft, which is going to be meeting its final end, crash landing into Mercury at the end of this month. And so look forward to those shows. And of course, we'll have lots of Clubhouse clips scattered around throughout. And of course, please do let us know if there's ever any object that you're interested in learning more about that we can see with the Slooh scopes. And we would love to do shows around what you members are passionate about, because these shows are, of course, shows that are all for you. So yeah, do give us your opinions on what you like and what you don't, and we would love to do some more shows that are in your ballpark of passions. So thank you again for watching this. And yeah, do you have any sort of maybe last remarks on what we've seen tonight, Bob? Because it has been, I think, a pretty beautiful show as the live imagery goes.
I love that. I mean, to me, it was really fascinating to see those globular clusters that were all discovered essentially the same time at the same people, all roughly the same distance. And so we could really compare them in terms of color and size and brightness. And that was very cool. I mean, the discoverers did not see the separate stars that we saw. To them, it was just like blurry balls. Our telescope is better than Charles Messier, who discovered it. It was actually about 11 years later before William Herschel actually wrote down, it's made of stars. It's not just a blurry ball, but we got to see that ourselves tonight. That was very cool.
Absolutely. It's really a testament to how far we've come, and how much potential we still have to go even further. And so, Slooh members have these opportunities at their fingertips, and a decade from now, a century from now, where in the world will we be? Well, it'll be quite a lot of fun to find out. So, as far as Sloohs goes on, we'll always be having live shows for you, documenting the universe and seeing what's happening live. And thank you so much for tuning in tonight. And we will be back again, of course, when something's happening in the night sky. So thank you again. And this has been Bob and Eric with Slooh.
Good night.
You can see sort of wisps of clouds along the side, but oh, let me tell you, the live views are just about coming in, and it's really looking like some sights that you are all going to very much enjoy seeing. So without further ado, I wanted to welcome Bob Berman, who's with us here tonight. Thank you very much, Bob, for joining us here. It's going to be quite a fun night.
Yeah, it's a pleasure, Eric. Very exciting. Very exciting.
Right. Right. And yeah, I mean, really, I'm seeing the view on the computer here, and I want to get this up because we have something gorgeous planned here. Let me get our heads actually out of the way. And here is the first star cluster of the night today live, M13.
Well, M13, what can you say? This is just gorgeous. It's maybe the most famous star cluster.
Hello and welcome to Slooh's latest Clubhouse clip. I'm Eric Edelman, broadcasting to you from the clear, beautiful skies at Smoky Hollow Studios in Slooh HQ, Washington Depot, Connecticut. Tonight I am joined by a Slooh astronomer, Bob Berman, who will be telling us a lot of very interesting things about objects that are very, very, very wonderfully, beautifully visible tonight. What we're looking at right now is the clear sky above the Canary Islands. We've had a lot of luck recently with some clear skies over there. There's a little bit of